Let's have a look at the hyperbola, a hyperbolic function. Is a function of the form that gives you a constant x multiplied by y is a constant. Let's say if I have the product of these two numbers being x and y is equal to a 4. This means if I multiply two numbers, I must get a 4, which says that when x is a 2, y must be a 2 to give us a 4. When x is a 1, y must be a 4 to give us a 4. But 1, we say 1 is equal to 4 over x. I hope you appreciate that x cannot equal to 0 because division by 0 is not allowed in mathematics. So x cannot equal to 0. Let's look at the other version. It can be here, which you can, let's take x will equal to 4 divided by y. Now, this also means that y cannot equal to 0 based on the fact that the division by 0 is not allowed in mathematics. So this gives us the restrictions. We say x is an asymptote, then x is equal to 0 is an asymptote. Here, y is equal to 0 is an asymptote as well. So basically what will happen is that if we have 1 here, 2 there, 4 and 3 there, we have a 1 here, 2 here, 3 and 4. Now you can, I hope this table will make things easy. We said x can never be equal to 0. So if this is our x, that will be our y. Let's say 1, 2, 4, -1, -2, -4. I deliberately skipped 3. Now, when x is a -4, if x is a -4 here, it's going to be 4 divided by -4. That is to say, y is 4. And when x is a -4, it's going to become -4. 4 divided by 4 is a 1, but this is positive, is negative. The answer is going to be -1. So it means here we're going to -1. We're going to have here -2, negative 4. We're going to have 4 here, 2 here, and 1. Now those are coordinates. When x is a minus 4, let's take x is positive 1 here, y is a 4. There they are. When x is a 2, y is also a 2. When x is a 1, y is a 4. Now, if you do that, now the same will apply here. Negative 1, negative 3, negative 3, negative 4, negative 1, negative 2, negative 3, and negative 4. When x is a minus 1, x is a minus 1, y is a minus 4. When x is a negative 2, when x is a negative 4, so oh no, this is a hyperbolic function where note k is positive. Now let's look at what happens when k is negative. From here, we know that a negative multiplied by a negative will give you a positive. That is why you have here x is negative, y is negative, so that we get a positive constant there. All right. Now, if we had y is equal to negative 4 over x, our table will look like this. Our table will look like that. Our table will look like that. And that will be our x. That will be our x. And that will be our y here. So 1, 2, 3, 4, minus 1, minus 2, minus 4. Now, when x is a 1, y will be negative 4. And when x is a 2, y will be negative 2. When that will be negative 4 over 3. And when x is a 4, that will give us negative 1. And when x is a negative 1, negative over negative is positive. We expect to get 4, negative and negative, positive 1. Now let's try to put this point on our Cartesian plane. When x is a minus 4, when x is a minus 4, our y is a 1, somewhere there. When x is a minus 2, y is a 2. When x is a minus 1, y is a 4. This will go up there. I hope you see that when the function approaches y is equal to 0, it goes to infinity. The same thing what happens when it approaches. This is 3, 2, 1, x becomes 0 here, it runs that way. So go for this one here. When x is a 1, y is a minus 4. When x is a 2, y is a negative 2. When x is a 4, y is a 1 there. The function must be like that. Now, if you write that, this will be xy is 4, then that will be y is negative 4 over x. Now here, x is positive, y is negative. That's why we have it there. Note, when k is positive, the graph is found in the first quadrant and the fourth quadrant. And when k is negative, like here, k is negative 4, it is found in the second quadrant, and this is the fourth quadrant. The mistake here is supposed to be the third quadrant. When k is positive, is in the first and third, and when k is negative, is in the second and the fourth. Okay. Hope you saw that. Now we are going to move to something else. We are going to shift the function in one direction or the opposite. Now let's see what happens if you have y is equal to 2 over x plus 1. Basically, the function will look like this. This part here, will give you this part here. If you never had that, if y was equal to 2, or if y were equal to 2 over x, we will have something going up this way and that way. Now, with this one here, we have 1 here, 2 here, 3 here, -1 here, -2, -3. And you can have your -1 there, -2 here, your 1, your 2, your 3 there. Now, this number will make your whole function to move up this way. Initially it was here, now it has moved up. Now, you can take your table as part of your exercise. And work on it. You will work on it this way. You can put your X here. Your Y here. And this one will be 2 over X plus 1. If X is a -2, this will be -1. If X is a -1 here, we'll have -2. If X is a 1 here, we'll have 2, we'll have 1. Now let's see if I have that plus 1, it's going to be 0. Plus 2 is going to be -1. And then plus that going to be 3 here. Plus 1 is going to be a 2 there. Now, when X is a 0, you can't work that way. You know, X cannot be equal to 0 here. But when X is a -1, Y is also a -1, somewhere there. Now, your graph has moved up, and this is called the Y asymptote. That is called the Y asymptote. Ndade, Ba ba etsa eng? ke tseba Weber Street. Ke tseba Weber ba go Wynberg ba bangata batho bana. Ao. All right. Thank you, Mranak. Your graph should look that way.